Hello everyone, and welcome to our Cosmic Classroom. Today we have a special edition for 3rd graders at Archdale Elementary School and their virtual family night. We will be talking about Earth's place in space, thinking about how the Earth moves, what that means for us, and where our planet is in space. Let's get started by taking a look at a more familiar location, your elementary school. Using our special astronomy software, we were able to add in this panoramic image of your school, and so we can see the sky exactly what it will look like for this location. Since we want to know what the sky will look like tonight, we can fast forward through time to let the sun go down, and we can start to see some stars. And we can see the sun makes its way towards the west, where it will set below the horizon. If you were going to stand outside your elementary school tonight around 9:30, this is exactly where the stars would be. Some of these stars can be connected with imaginary lines to form constellations, different figures that break up the sky into 88 sections. There are several constellations we can see in the sky tonight, but let's take a look at 2 related constellations towards the north. Looking to the left of your school, we can see Ursa Major, the Big Bear, and nearby Ursa Minor, the Little Bear. And at the tail end of Ursa Minor is a very special star called Polaris, or the North Star. A trick to find these constellations is to first find a bright, famous shape in the night sky, the Big Dipper. The Big Dipper is not a constellation, but is actually an asterism, a shape made from a group of stars that is a small part of a larger group. So here, the Big Dipper is a part of the larger constellation Ursa Major. We can also use the Big Dipper to find Ursa Minor. Looking at the top edge of the scoop, there are 2 stars called Merak and Dubhe. Drawing a line down from Merak to Dubhe, you can then Scooby-Dooby-Doo your way over to Polaris, at the tail of Ursa Minor. And just like Ursa Major, Ursa Minor also contains an asterism, the Little Dipper. Not only can Polaris help us find this constellation, but it can also help us find north, which is why it is called the North Star. Let's figure out why this is possible. Every single day, the sun rises in the east and sets in the west. And the stars we see in the sky actually follow this same motion, which we can see when we let time move quickly. But if you look closely to the north, you can see one star does not move at all, and all the other stars seem to circle around it. And that one star is Polaris. But why does this happen? We know that Polaris must always be in the north if it can help us find this direction. And now we can see that it does not move or rise and set below the horizon like the other stars. So if we think of a spinning top, we can see something similar happening here, where the center part stays in the same spot even when the whole top is spinning. That's almost the same thing if we think of the Earth as a spinning top, where the North Pole and the South Pole are the 2 spots that stay the same. Looking at the Earth from space, we can see the Earth spins on a rotational axis that runs from the yellow line to the blue line, and it takes the Earth about 24 hours to make one complete rotation, which is what we call one day. If we look straight down at the North Pole, we can see the point right on the axis does not move at all, and the same thing is happening down at the South Pole. Everywhere else makes a circle as the Earth rotates. Since we are in space looking down on the Earth, we can see that the Earth is the one that's rotating. But if we are on the surface of the Earth, instead, the sky looks like it's rotating. And so this is why we see the stars appearing to move across the sky, since our perspective is changing as we rotate. And since Polaris is right above the North Pole, it appears to stay still in the night sky, which is why it is always visible. And so if you can find Polaris in the night sky, you will always know which way is north. Throughout the year, the other stars we see appear to change their position in the sky, and sometimes will disappear out of view for months at a time. For example, there are certain stars that we can see only in the spring or in the summer night sky. At different times of the year, we also have days that are longer, like in the summer, or days that are shorter, like in the winter. And just as the path of the stars appear to change throughout the year, so does the path of the sun. Let's take a look at the path for a few different months to compare. Here's the current path of the sun across the sky for the month of April. And if we look ahead 1 month to May, we can see it gets a little bit higher. And then in June, it is a little bit higher again. So why does this happen? We know that the sun and the stars rise in the east and set in the west due to the rotation of the Earth, but what makes the height of the path of the sun change over time? This is due to the other motion of the Earth, its revolution. This is the movement of the Earth around the sun. When we make one complete revolution, or orbit, around the sun, we call this 1 year. Our revolution around the sun, combined with the fact that the Earth is tilted on its axis, causes the sun to appear at different heights in the sky. This also gives us the seasons. While our tilt on our axis does not change, our position around the sun does, causing different parts of the Earth to lean towards or away from the sun at different times of the year. From our point of view on the Earth, we see this as the sun being higher in the sky in the summer, and we have warmer temperatures. And then during the winter, the sun is lower in the sky and it is colder. This is also why we see different stars and constellations during the different seasons, since we are changing our position in space, and the stars that are within our field of view are changing. So these two different motions, rotation and revolution, happen at the same time. The Earth rotates on its axis, so we have day and night. At the same time, it orbits around the sun, which is why we have the different seasons, and each full revolution is 1 year. But we are not the only planet that moves like this. In fact, we are just one planet out of 8 that rotates and orbits around the sun. This collection of planets, along with other objects around them, like asteroids and moons, make up our solar system. And all of the planets in our solar system have these 2 types of movement happening at the same time. However, not all of them do it in the same way the Earth does. For example, we can see that Mercury moves much faster around the sun. In fact, 1 year on Earth is equal to 3 years on Mercury. So in Mercury time, you are all actually 24 or 27 years old. Meanwhile, looking far, far away to the outermost planet in our solar system, we see that Neptune has the longest orbit, taking almost 165 Earth years to travel around the sun just once. That's longer than we've had the Statue of Liberty. We also have some planets that rotate on their axis funny. One of our neighbor planets, Venus, is very close in size to the Earth, but it rotates backward, which means the sun appears to rise in the west and sets in the east, the complete opposite of what we see here on Earth. It also rotates so slowly that 1 day on Venus takes almost the same amount of time as 1 year on Venus. Taking a look at Uranus, we can see another weird rotation. While this planet also rotates backward like Venus, it does it on its side. This is because its rotational axis does not point straight up and down. Uranus also has the shortest day out of all the planets, taking only 17 hours to make one complete rotation. And so sometimes in our night sky, or in the early morning hours, we can see a few of these planets. Currently, Mars is visible in our night sky, right after sunset towards the west. Speaking of current events, we heard that one of your classmates, Melvin, has a birthday today. Let's travel back in time to look at the sky for the day you were born. The constellations Ursa Major and Ursa Minor were both visible that night as well, and so was Mars. But 2 other planets could also be seen, Venus and Saturn, making a total of 3 planets visible in the night sky. From us at the Cult Planetarium, we hope you have a very happy birthday. Now that we know how the Earth moves and how this affects what our sky looks like, as well as a few different things that are currently visible, we challenge you all to find them in the night sky. The 2 asterisms we talked about, the Big Dipper and the Little Dipper, and the planet Mars, and a constellation can all be spotted starting around 8:30 tonight. This new constellation that we did not talk about is a close cousin to your mascot, the panther, and will be nearly overhead throughout the spring. We want you to look for Leo the lion. And remember, if you can find the star Polaris, you'll know which way is north from your own backyard to help you look for these different objects. And even when you are not completing this challenge, don't forget to keep looking up.